So we're going to be talking about three things if we get through all the topics today. One is the idea of hash maps. Python calls them dictionaries. The idea behind that is, wouldn't it be cool if you had some kind of, right now we can do this, right? We know how to do that.
Excuse me, are you recording?
Yes, I am.
Oh, okay.
Thank you. You're my new best friend for asking me. All right, so, we know how to do that. We create an array and we start sticking things in there. But what if we could do things like this? Now, that's not the syntax in this language. That's the Python syntax. But it's the same idea, right? Instead of a subscript, you specify a key. So we're creating key value pairs. So if we want to find Fred's age, we can look up Fred's age. Fred's age is equal to 3. If we want to find Bob's age is equal to 25. So we can tie together keys and values. That's what hash maps are. But I want to go back to the idea of inheritance and explicitly abstract classes and interfaces. So we've seen inheritance. You've seen it before. The idea behind inheritance is you have superclasses and subclasses like this, which illustrates is-a relationships. An employee is a person. Full-time is an employee who is a person, and so far. And each one of these adds, hopefully, otherwise there was no reason to create it, more members or more methods, more functionality than the class it's extending. Well, an abstract class is just one that doesn't provide, that leaves some of the members undefined, so that you have to create them. There's no way you can not create them. It means that the superclass doesn't have an implementation for it. It's just that you know that there's going to be one. So in this case, we might have some method here that was marked as abstract, and it meant that when the customer class was created, then they would have to implement that. They would have to override it. They'd have to give it a body. The method would actually have to have a body, or else it wouldn't compile. So I'm going to play with that idea a little bit. Well, why don't I actually do it inside of NetBeans to make sure it compiles adequately. I'm going to create a shape superclass, and it's going to have an abstract method called getPerimeter, and we have to implement the getPerimeter method, or else our code will not compile when we create some child classes, some subclasses based on that, classes that extend it. So that's what we're going to want, is we're going to want an abstract class named shape. It's going to have an abstract member named getPerimeter, and any class that inherits from that, right, like a triangle class, circle class, because I know how to calculate the perimeter of a circle really well, right, that extends the shape class, has to override getPerimeter, has to provide a body for it. Or it could say that, oh, by the way, I'm an abstract class too, and then it can get away with not implementing it. Go. Do not take so long. Oh, by the way, guys, if some of y'all need to take the exam and you can hang out, come with me to my C. By the way, guys, if you need to take the exam and you want to hang out after this class, come to my C++ class. Come in at 7:10 so that the regulars have already chosen their seats, and then you can just come in and take the exam, all right? Get it knocked out of the park today if you want to do that. Otherwise, I have extended the deadline, till, a week. But it'd be cool if you got it done today, because then it could get graded, and if you want to take it again, you'd have a second shot at it.
Are they taking their exam today? Or?
If anybody wants to. No, they're not. You'd have to go blah, blah, blah and ignore my blathering, but
So we'd have to ask you for the password.
I'd give you the password, yeah. But everybody's good at ignoring my blathering anyways, aren't you? No, I'm kidding. I am teasing.
That's why we're early early so we can ignore more.
That you can ignore it longer. Right, okay, so we're doing lecture M now,
Oh,
I believe.
Not L.
I got L.
We're on L?
Yeah, that's what I have.
That could very well be. Oh, you're JK. Yeah, there needs to be an L. In fact, L is completely not on my map. Okay, this is the missing mystery lecture that nobody else ever got. How about that? Lecture L. So what I'm going to do is I'm going to declare an abstract class. But let's say I don't know the keywords yet. So I'm going to declare a class, call it shape, and it's going to have a get perimeter method. But I'm not going to implement the body of the get perimeter. So, but it does need to return an int or a double or something like that. Double, get perimeter. And no, I'm not going to give you a method. I'm not going to give you a body. Well, to get away with that, we have to mark it as abstract. And now it's complaining. Shape. If I have any abstract methods, I am an abstract. Whoops, I put the word abstract at the end instead of beginning. Okay. If there are any abstract methods in the class, it has to be an abstract class. Now, not every method in it has to be abstract. You know, we could provide a toString method or something like that. How about an equals method that will compare two shapes based on their perimeter? And if they happen to have the same perimeter, then we're going to call the shapes, you know, the same thing. So, Boolean equals, parentheses in parentheses, and it's going to take an object. We don't know what kind of object. You know, realistically, you could put shape here, but then what if somebody else tried to pass in another shape? I mean, another object there. I'm going to go ahead and call it shape and then worry about casting it later, not to make this overly complex. So other, shape other. Here's our Boolean method. It accepts something else. Now I remember why I have to make it of type object rather than shape. Everything in Java inherits from the superclass called object. And if we want to override the equals method, then we have to match the syntax. You complaining because we don't have a body yet? All right. So he doesn't like the fact that we haven't declared him as public. I'm willing to abide by that. And of course it doesn't like the fact that yeah, just for grins, I'm going to make it return false. Right. We can go back and implement it more correctly later. And it wants us to add the @override notation. The reason you add @override is so that if you declared it incorrectly, the compiler will catch it. That's all the @override means. It's not necessary, but it tells the compiler, oh, you are overriding an equals method, so I'm going to check my superclass and make sure that you've done so, that there was a method of the same signature. The signatures consists of the return type and the parameter types. All right. The only reason I added a .equals method is to show that abstract classes, not every single method has to be abstract. One of them is. You could have 10,000 other methods in it that are not. All right, let's make a shape or two. Let's make a triangle and a circle. So, class triangle. Is this text big enough? Does it need to be bumped up one size larger?
Okay.
Brian's the one in the back row. He needs a telescope. Brian, if you need me to crank it up, let me know. All right, so class triangle extends shape. Great. Now it's complaining. Since triangle inherits from class, since it extends class, it's not a complete thing anymore because it doesn't have a get perimeter method. That's what this says. Is every shape better have a get perimeter method. Triangle is not abstract and does not override abstract method get perimeter. Yeah. Well, we'll put one there. For one thing, we have to figure out how a triangle calculates its perimeter, what kind of data it is. And I'm going to make it really lame and easy and just say that we have 3 sides to a triangle and that the perimeter is all 3 of them added together. Now, I'm not going to add a get area method because I have no idea quickly how to calculate the area of that, but this will work. So let's declare our variables. Double side 1, comma, side 2, comma, side 3, just because we need 3 pieces of data. We may as well add a setter for those guys, a constructor. So public triangle, parentheses, double side 1, comma, double side 2, comma, double side 3. And since it's a constructor, it needs to set these values. So this dot side 1 equals side 1. This dot side 2 equals side 2, and so on. I really would like it to be slightly bigger. It's already on 24. 26, 27. All right. Okay. So this dot side 1 equals side 1. This dot side 2 equals side 2. And this dot side 3 equals side 3. Now we have a constructor just to make it easy to make a triangle. And if I was going to take the time to make this a well-implemented class, I would make the data private, add getters and setters. I'd add a toString method, maybe a dot equals method. Okay, so here we go. Now we need to implement our get perimeter method, and its signature needs to match exactly this one, meaning it has to have the same return type and the same parameter list. Well, this is easy because it's got a return type of double and no parameter list. Okay, let's put one in there. I didn't make this public. Why not make it public? Public abstract double. I've mentioned this before, but if you leave off public, it's a slightly more limited version of public. Unlike C++, where if you leave off public, it defaults to private. It's kind of harsh. Okay, so public. Now we're not going to call this one abstract. It's not abstract. It's actually going to have a body. Public double get param, parentheses in parentheses. And what does get param do? It just returns side 1 plus side 2 plus side 3. Return side 1 plus side 2 plus side 3. All right, now the class will compile. Would not have compiled if we'd left this out. And it really wants us to add the @ override notation, so why not? Add @ override notation. Be a good time to stop and make sure everybody's code compiles. Not going to do anything right. I didn't put anything in main, but it's there. Mine compiles. Let's make sure y'all's do. If get perimeter was defined as private, then when we try to override it, we wouldn't be able to do it. Whoops, I put that in. Yeah, right. I have made this one more restricted than the abstract method was called. All right, now we can make another class based on the same idea. Let's make a square class, and the reason I'm suggesting a square is because it only has one parameter, right? And so its constructor will be simpler. So, class square extends shape given an itty bitty constructor. Public square int side, but I need a side instance variable to hold that. So I'm going to wind up putting a variable above that declaration. So above public square, we better do. Apparently I've chosen that this thing can only hold ints. That's not wise. Let's make it a double. Double side, and I need to change that int side to double side. And then this dot side equals the side of the parameter variable. Then we're going to need to add a getParam method, and all it's going to do is return 4 times the side length. So public double getParam parentheses in parentheses colon return 4 asterisk side. All right, now we could go down into main and create some triangles and create some squares. I really would like to do that dot equals method though. So I'm going to scroll up. I can scroll back down and let y'all type in anything you missed. But anyways, I'm back in the shape class. Inside dot equals, the first thing I have to do is convert it into a reference to a shape. And so I need to make sure it is a shape. Because if it's not a shape, if whatever we're passing in, a triangle or circle or whatever, is not a shape, then we need to rule that out immediately. And again, I have forgotten the keyword to check to see if something is instance of another one. And we just did this last week, and I can't believe I don't remember it.
Isn't it literally just instance of?
Is it just instance of? All right, so if parentheses other instance of, is it capital? Yay! All right, thanks, guys. If other is an instance of a shape, but if that's false, right, then we're going to return false. It's definitely not equal if the object being passed in is a shape, which would be possible, right? Since it's just taking a generic object, somebody could pass in absolutely anything except for a primitive value. We could pass in a scanner and try to see if it was equals to our shape. But we wanted to say false in that case. All right, now we know it's safe to cast other to be a shape reference. How about just shape sh equals parentheses, shape in parentheses, other, right? Now we can do some comparisons, but there's only one comparison that we're going to do. We're going to check to see if their perimeters are the same. Double P1 is equal to this dot get param parentheses in parentheses. Same thing, double P2 is equal to sh dot get parameter, the other shape, the one that we want to compare it to. And now we're going to return whether those are equal or not. Return parentheses, don't even need the parentheses really, P1 equals P2. We'll test that out for funsies. We'll create a square that has a perimeter of 4 and a triangle that has a perimeter of 4 and see if they are equal according to this method. Alright, so I'm scrolling all the way down to main. Does anybody need me to slow down or come help with typos? Wave your hands in the air like you just don't care. Here we go.
Our computer science class, we don't do that.
Yeah. Alright. So we're down in main. Let's create a triangle. Triangle T1 is equal to new triangle. Parentheses in parentheses. Why am I getting an error? Oh, because we have a constructor. We have to fill in the values. This triangle is going to have a side 1 of 1, a side 2 of 1, and a side 3 of 2. 1, 1, 2. Why that? Because I wanted to add up 4, so if we make a square with a side length of 1, it'll have the same. Right. And then square S1 is equal to new square with a side length of 1. Let's find out if they're equal. Boolean equals not liking that. Boolean same equals equal sign T1 dot equals S1. Like that. And we can print out whether they're the same or not. System.out.println. System.out.println parentheses T1 equal S1 question mark space end quote plus same. It'll print true or false. Parentheses semicolon. All right. Yep. T1 is in fact equal to S2. Now let's change one of the parameters. Make it say 1, 2, 3 or something so that they're no longer the same. 1, 2, 3. Now when I run it, nope, they're no longer the same because they no longer have the same parameter. One thing to note about that is that equals was able to use get parameter even though get parameter was not embodied in this class, right? Yeah, we called this .get param. Even though that guy doesn't have a body, it works. And that's because the compiler figures out which version of get param to use, right? And since triangle is a shape, then when we're calling .equals on our shape, and we call get param, then it would run down here. It would run the get param method out of the triangle class. Come back up here. Why did we put equals here rather than down here? Good question. I'm going to try an experiment. Don't follow along with me because I want to find out if this fails or not, and I don't want you to make a whole bunch of changes. I cut .equals and I'm putting it inside shape. Wait, I didn't want it in shape. In triangle and in square. And I want to see if it compiles. And somehow magically it does. Since that method is provided in both of our inherited classes, it did work. But that means that we have to provide that method for every class that we want to be able to use it. And that'd be kind of a drag. Right? That's duplicate code. It's the exact same code in two methods. There's no reason to do that. If you have the exact same code in two classes, I said methods. If you have the exact same code in two classes, it probably ought to be moved up to a superclass. So let me undo those changes. Now what are you complaining about? Why? Generate missing hash code. What did that do? I don't see a change. Generate missing hash code. Oh, I have the override thing there, which is, oh, well, that's correct. Because we're overriding the equals that the method class gives us. What in the world are you talking about? I just flat out don't see any change being made to it when I do that. Is it something down at the bottom? I just saw this close brace move down by 1. Oh yeah, what do you know? Huh. I don't know why we need that, so I'm not going to worry about it. I'm going to undo that change. And I saw something else. I thought it was complaining about this, but now it doesn't seem to be. I thought I saw a reference there. All right. Okay. So we've seen an abstract class. I think I'm since. All right, so now we're going to cover the idea of interfaces. In C++, you can inherit from as many abstract classes as you want. You can make 17 different abstract classes and inherit from them all. And that gets confusing because what if each abstract class has some methods with the same name? How does it know which one, right? It's referencing. It works. They get it to work, and as a programmer, you figure out the syntax required. However, Java makes it so that you can only extend from one abstract class. Now, that doesn't mean that that abstract class can't be a child of another abstract class, can be a child of another abstract class. It just means that you cannot say, oh, by the way, I want to extend class 1 and extend class 2. But we have another tool which will let us do that called interface. And an interface is an abstract class. In effect, it's another kind of abstract class. And what you're supposed to do with it is just purely define methods that your class has to implement. That's why I called it an interface. So you might have a object called printer and a class called printer, and every printer has to have a add to queue and a restart method and something else. And so you could make that an interface. You could say, this is an interface called printer. And then for every kind of printer you create, it could implement those methods. That's kind of an abstract, that's a little bit too abstract. Why don't we just give an example of that? So I'm going to come down here, and here's what we're going to do. We're going to create two interfaces. One is called farm animals, and one is called lab animals. But they are both animals. These are going to be our interfaces. And lastly, just because we're in a inheritance kind of mood, we're going to make a superclass called critter. And everything is going to extend a critter class, but then we can decide whether it's a farm animal or a lab animal or both. So let's make our critter class first. Class critter. Did not mean to put that S there. Class critter. Every critter has a name. So string name.
I mean, in labs now, they get numbers.
I mean, you could still technically argue that's a name.
Well, if you want to put it like that, sure.
Yeah, you're right. If it's a lab rat, they're only getting numbers. We're not calling them names because giving things names brings you grief when you have to do mean things to them.
I mean, I guess calling it identification would be better.
Okay, how about ID? Yeah, we're going to call it the ID.
Yeah.
All right. And now we're going to define two interfaces. Interface lab animal. And I'm going to go down here and go ahead and add the other interface just to get my braces in the right place. Interface farm animal. All right, what's the difference between a lab animal and a farm animal? A lab animal we do experiments on. I'm just kind of making this up as we go along. How about we, just like you said, the lab animal class. No. Let's ignore that. So every lab animal needs an experiment method because we want to perform experiments on it. So public Boolean experiment, parentheses in parentheses, but it's going to be an abstract method. We don't need to define it as an abstract method because every method in an interface is abstract. That's worth putting as a comment. Let's prove that. I'm going to make a silly little method. I'll delete it. Public void test. Right. It started to yell at me as soon as I tried to provide a method for it. All right, now somebody come up with a something that you do with farm animals that you don't do with lab animals. All I'm thinking is harvest or butcher, and that's kind of bleak.
You can milk them.
All right, yeah, we can milk our farm animals.
How about killing them? I feel like that's better than
Harvest. Okay, we're going to harvest our poor farm animals. Okay, so public Boolean harvest. Parentheses in parentheses that. Why don't we make these strings though? Because we can make them return something interesting when we do it. Right, like if it's a sheep, it'll return veal when you harvest it and stuff like that. Alrighty. Now we're about ready to actually start creating some critters.
I'd rather be a lab rat at this point.
Yeah. Well, the lab rats eventually get harvested to see the results of the experiments, but we won't think about that. Okay, so class rat extends critter implements lab animal. And we're getting a complaint here. Oh, because it does not override the abstract method experiment. When we say implements, that means that we are guaranteeing ourselves that we're going to have an implementation for the abstract method there. So we're going to have to add an experiment method. And let's add a constructor for it so that we could set the name of the animal. Public rat, parentheses, string name, like Vincent says, we're only going to number our poor rats, in which case it could be an int. So public rat, parentheses, int, num, in parentheses, and what we're going to do is we're going to call our super constructor. Well, we don't even have a constructor that this will work with, so I'm just going to do that. Call it the default constructor because that's all we have up there. And then we're going to set this dot name equals to rat space end quote plus num. Is that good enough? Will it convert it to a
It's
ID? Yeah, thank you. This dot ID equals rat plus a number.
I ruined your whole thing.
You broke my brain. All right, there we go. Now we have to also add our experiment method. Public string experiment. And what does this experiment prove? Return rat squeals when tickled.
Wow.
There we go. Now what's it complaining about?
Experiments couple E.
Oh yeah, well that shouldn't have been because it's a method. Come back down here and make experiment, I'm sorry, whatever case you made your experiment method. Uppercase, lowercase. It should have been lowercase just because Java guidelines or methods are lowercase, classes are uppercase. All right, now we're not going to add a harvest method because a rat is not a harvestable animal. Maybe. And I'm going to go ahead and let it add the @ override. All right, now people do raise guinea pigs for meat, and they do experiments on them. So maybe we'll make a guinea pig class which implements both of those. Now the fancy name for a guinea pig, I believe, is Cavi or Cavi. I'm not sure how you pronounce it.
Wait, so you can implement it?
Pardon me?
You can implement both of them?
Well, we could put a harvest method in there. It's just we'd just be doing it for fun. It's not necessarily part of it being a lab animal. So I'm going to leave that one alone. What I would do is I would say that it implements both the lab animal and the farm animal, and that's what this one's going to do. Class Cavi, which is a guinea pig, extends critter and implements lab animal, comma, farm animal. Critter is supposed to be uppercase. You don't have to break it into 2 lines like I just did. All right, now we get into a conundrum where are we going to give it a name that's a friendly name like I was thinking we would for farm animals, or a number? So why don't we create 2 constructors? One where if we pass in an integer, we're going to give it a name that's an ID number. And if we pass in a string, we're going to set that instead. So we need 2 constructors. Public critter. The very first thing is we do call the superclass. So public critter, curly brace, super. Why is it messing up my tabbing? Because I didn't give it a return type? No, constructors don't need return types. I have done something and it's complaining all over the place. For one thing, I have too many close braces. So y'all can take comfort in the fact that I do that too. Oh, because we're not, our constructor should not be called critter. Our constructor should be called Cavi.
You need a passive one.
Does identifier expected under carry?
Oh, yeah, we do. We need a parameter list because a constructor needs a parameter list. Hi. You're going to have to watch the first 30, 40 minutes of the video to catch up. This is not going to make sense. Okay, so,
Learning how to harvest animals.
yeah, we're learning how to harvest farm animals.
That's awesome.
Okay, and so we call the superclass, but this critter, this is a type of critter that is a lab animal, so it's going to take an ID number. And so this dot ID equals, quote, Cavi space end quote plus ID. I'm still getting errors.
You made it critter again. Right?
Yeah.
Why did I? Okay. Make that line Cavi. Like I failed to do 2 times in a row. Thank you. Now I'm going to make another constructor that looks just like that. I'm overloading the constructor, except it's going to be string. And then that way we can set the string. That's needlessly complex, but all right. So string name. There we go. I did some judicious copy and pasting. All right, now since this is implementing both lab animal and farm animal, we have to put both an experiment method and a harvest method. And I really don't want to go and add those until everybody who's typing along is happy where they're typing. We need to give ourselves an experiment method and a harvest method. So public string experiment, parentheses in parentheses. And whenever we experiment on a guinea pig, he eats a carrot. Return quote, KV eats carrots real good. That is an override, so I may as well let it add that. And this is not going to make a lick of sense to you without the preceding stuff, so you're definitely going to want to watch the video. But we're going to move on to another topic as soon as we finish this part. And let's do the harvest one. Public string harvest, parentheses in parentheses. And when we harvest our poor guinea pig, we return yum. That's good eating. And if we were awesome, we'd add a toStrings method and a equal, and you know, all the niceties. So down here in main, I'm going to create a rat. Rat Ricky is equal to new rat. That's rat number 1. Cavi Ralph is equal to new Cavi. He's lab animal 2. And then Cavi Bob is equal to new Cavi, but he's actually a farm animal, so we're going to call him Bob. We could add them all to an array list of shapes, excuse me, not shapes, of critters. Or we could just call those methods to test them out, right? So R1 dot, let's do system dot out dot println parentheses R1 dot experiment. Excuse me, his name is Ricky. Ricky dot experiment. And then system dot out dot println. All of them support the experiment method. So let's Ralph dot experiment, and then system dot out dot println parentheses Bob dot experiment. I've decided I want to change the way some of those methods work so that they include the name of the animal or the ID of the animal, but some other time, or at least in a few minutes. All right, and then since we can harvest Ralph and Bob, but we cannot harvest rat, if I did Ricky.harvest, doesn't know what it is. System, I should copy and paste the word system.out.println for efficiency. Ralph.harvest, parentheses in parentheses, and system.out.println Bob.harvest, parentheses in parentheses. All right. I can scroll back down to this, but I want to modify the harvest and the experiment methods a little bit. So instead of saying KV eats carrots real good, it's going to say the ID of the critter. This dot ID plus quote space, like that, right? Same thing for harvest. This dot ID plus space. Same for up here with the rat. Return this dot ID plus quote space. All right, and here's our little petting zoo full of animals. Rat 1 squeals when tickled. Cavy 2 eats carrots real good. So does Cavy Bob. Cavy 2 is good eating. So is Cavy Bob. And our shapes are not equal. Okay. Do I need to scroll back down to the print lines?
Mine says Cavy no.
Okay. Do both of your cavies say that?
No. It says Cavy Bob and Cavy no.
Okay, take a look to see if you have this method here. The one that takes a I. Make sure it has that line in it. All right, I want to go look, see. Composition, inheritance, pinky bang. See if we're ready for homework 12 based on that lecture. That's boring. But I made y'all do dessert in the first Java class, right? Maybe not, did I? Create an interface that has get cost. This is looking familiar. And then create a candy and a cookie and an ice cream. Did y'all do that?
Yeah, that sounds familiar.
Well, I may give it to y'all again, because half the class has not done it. I should come up with another one, no, but it would look very similar.
It's okay. If we can borrow that code from first class.
All right, I'll come up with another one.
You can do something more with format.
Do what?
You can do more with format. Yeah. Maybe some of them you have to shear.
You ride, some of them you castrate, some of them you put things in your shirt.
Way to go all in on the morbid.
Well, I mean, we started off with lab animals and farm animals.
Right, it's my fault. Okay,
I was
Cruelty
thinking-
surrounding both forms.
so we're going to make an abstract superclass.
Stars, lab animal number 1.
And the abstract superclass is called shape. And it's got a name. And we're also going to have to provide a toString method for it. That prints the name of the shape. Then we're going to have two interfaces. Two interfaces. One is called 2D. It's a 2D shape. And if it's a 2D shape, it needs a get area method. And the 3D one has got a get volume method. I had a better version of this, and I really thought that it was in our assignment list. I reserve the right to make it slightly more elegant by the time you start working on it. But if that ever happens, if I ever revise the instructions and you were using an old set of the instructions, you can always turn it in and get full credit because it's not fair for me to demand you go back. So, make some shapes like a rectangle versus a block, and then a circle versus a sphere. And each one will need a rectangle is a shape and implements 2D shape. A block is a shape and implements a 3D shape. Circle is a shape and implements 2D shape. And a sphere is a shape and implements a 3D shape. Now, I haven't come up with a compelling reason for us to even have an abstract class that these things extend, except to give them all a name. I'm going to remove the toString method as a requirement for now because I'm not coming up with a good way to play with it. But every one of our class says need a constructor that will set the name of it. So you're going to need to create those 4 classes. Every class needs a constructor that sets its instance variables. You can pick what instance variables a circle versus a block versus a rectangle needs. And sets the this.name method member. It will also have to call super. And in fact, the call to super has to be first, or else it just won't compile. Then have your code create a rectangle, a block, a circle, and a sphere. And call the appropriate methods on it. That's just about enough. But there's one more thing that I want you to try to do. Try this. You know, a sphere is just kind of a fancy form of circle, right? So, add a constructor to the sphere class that accepts a circle as its argument. And does something appropriate with it, right? So if it's a circle of radius 10, the sphere should now also have a radius 10. Then add a .2 equals and a toString and no, I'm kidding. That's enough. This is enough. I think this will demonstrate that you have the idea of inheritance versus. Our abstract class doesn't have any abstract methods, so it doesn't need to be an abstract unless I came up with something more awesome. I'll write this up in a much more legible fashion, right? Cute little Word doc. Does that make sense? No, it's not going to make so much sense to you. You'll watch the video and it'll make sense, I promise. All good?
I do have a question. It's not about
Right.
what if the 2 interfaces both had a method named the same thing?
Let's figure that out. What? Because that's the same problem I was talking about with C++ when you inherit, 2 abstract classes. Let's find out. So the question is, what happens if our interfaces both have the same method? How do we implement them both? Good question. So, I'm just going to make a void method called eat, right? Public void eat. You don't have to do this because we're off in la la land. We don't know whether this is going to work or not. And also the farm animal has one called eat. Now my guess is that that just means that we have to go and add an eat method to every one of these guys. And it'll satisfy the fact that both of them need one. Right? Public void eat. System.out.println. Nom nom nom.
Getting that green dot of death error again.
And he is complaining. Oh, that's a warning. That's all right.
There's a green dot.
That's just information, apparently. Yeah, this is saying, oh, by the way, what is this override? And if I click it, it takes it to that one. Okay, but what if they had different types? Right? What if farm animal had something called void eat, and then this kind, the lab rat, has something called string eat. And so this method will no longer satisfy both of those categories. And it lights up like a whole bunch of errors. Let's see. Rat is not abstract and does not override abstract method eat and lab animal. Well, true. And what if I tried to add one, right? Public string eat, and this is going to cause another error. Return nom nom. You can't have two methods with the same parameter signature but different return types. So it's complaining about that. So in other words, if you wind up in a situation where you have two methods defined in your interfaces with the same name but different return types, you've set up an error that I don't think you can resolve. I'm going to undo all those changes, if that's okay with y'all.
So just strap doesn't allow the same.
You need to stop that. I'm sorry, Simon. I didn't hear your last statement.
Just strap doesn't allow methods with the same names if they're from different interfaces.
Okay.
What if they're different return types? What if they're the same return type, but you wanted them to act differently depending on what kind of interface you're using? But ended up using both of them in the same one. Does that make sense?
I don't see how that would work. So no, I don't know how to pull that off. The reason for that restriction about having different return types is if you had something like this, int test, and it took an I, and then you wrote one string test that took int I, and then later on you wanted to call one of those, but you didn't store it, you know, its result, and you just passed in 10 like that, it wouldn't know which one to hook it up to. The compiler would not be able to stitch it correctly. And you might think that you could do this, int x is equal to that, and then it would stitch it up to that one. But the compiler says that no. It does not look in advance to determine which kind of method it would call based on what it's going to be stored as. That's a bit too much for the compiler to figure out. So are you saying that you know of another language that does let you set that up? Or?
I'm just asking, like, if
Okay.
they had the same return type, like the cavity was both a lab animal and a
Right, and so if they have the same return type,
if they had the same method and same return type on that method, how would it know which one to use?
because we provided one eat method, there is no decision about which one to use. There was only one eat method in the cavity. And the fact that we had an eat method fulfilled the requirement that both lab animals and farm animals have to have that. That kind of makes sense. Like, if that's the case, if that's really the case, though, we should have just made that a member of the superclass. Right. But no, we could not make the eat method behave differently for the heavy based on something or the other because, yeah. Okay, so that's about enough of that, and we do have some time left. So let's cover the idea of doing some file I/O, just on the off chance that your project involves file I/O. By the way, I'm going to make drop boxes, so, temporary drop boxes so you can upload things into them, showing me the state of your project, just to kind of nudge you, right? Make sure you're working on your project, because if you wait until the last week to work on your project, then you're not going to turn in a very good project. And I would also like to offer you the idea that if you get done with your project in a week or two, then if you feel like doing a second one and skipping the final, you can do that. So file I/O. Reading input from a file can be just as easy as using a scanner to get input from the keyboard. Make sure I do this right. Because the scanner will accept an argument. It says, scanner system.in. But the scanner will also accept an argument for its constructor, which is a file to read from. All right, so that's supposedly chapter 16, and I don't know why that's so far back. Really, files ought to be like the third thing we learn, chapter 3 or something, as soon as we learn to use scanners. But that's okay. It's important to cover, so we're going to go look. This is actually going to cover some stuff that we're not going to take the time to cover. Walking a directory tree with a glob pattern matcher. Well, I do want us to show how to go through a directory tree, but that's going to be a different lecture than just reading from a file. Alright, don't know why I'm not finding it there. What, did I rely on my own PowerPoints for this because that one was inadequate? Oh. All right. So in main, or maybe I'll just make another method for it and have main call it later. I'll do that. I'm going to scroll all the way up to the top and make a new method. No, that's getting confusing. We'll do it down in main. In main, I want to write something to a file. Or I want to read something from a file, as a matter of fact. So here's what I'm going to do. File F is equal to new file, and I'm going to pass in a name of the file that I want to be able to read from. Test.txt. Now I don't happen to have a file called test.txt yet to read to. So I would probably want to create that file, but I need to add an import for java.io.file to get that to work. Let's go ahead and create that file beforehand. And the PowerPoint actually does demonstrate that quite well. So we're going to use a Printwriter class to create our file. Printwriter creates simple text files. If you need to store binary data, you would not use print file. But with print file, it's about as easy to print to the screen as it is to use print line. So let's create a Printwriter object. Printwriter pw equals new Printwriter. And let's move that one up above here. I'm moving file F there, and I'm going to pass file F into the Printwriter, into the constructor. And now I see why it's in such a late chapter. I forgot that we have to show try and catch in order to get file IO to work. Well, so be it. Exception handling. I bet a lot of y'all already have the idea. But what exception handling is exception handling, if the program gets into a state that would crash it, then you can use exception handling to try to fix that, like divide by 0. And some of these things are so fraught with peril, like trying to read from a disk. There's so many things that could go wrong, right? The disk could stop working. It could be filled up. You may be trying to refer to a drive that has been removed. That kind of stuff that you have to add exception handling before it will let you get away with finishing, before it will let you compile it. So what you have to do is you have to enclose your dangerous code in the word try. And it's complaining that we don't have a catch. And the reason I did that is because it's complaining that Printwriter will throw an exception that must be caught. So I'm going to add a catch clause. All right, and here's our catch clause. If we get a problem, it's because we could not open that Printwriter file. I'm just going to add a system.out.println, quote, file not found here. I should print out the name of the file. I'm being really extraordinarily lazy, and I'm not, putting that in a string variable, but y'all know how to do that. Wouldn't it really irritate you to use a program and it said file not found, but it didn't tell you which file? Okay, so now we have the Printwriter file. Let's save some data to it. pw dot, we could append a character to it. We could print something to it. We can do anything. We can use print line, our good old print line. pw print ln parentheses quote, look Ma, I created a file. But let's be a little bit less silly. Let's write out some numbers. 100 pw.println 200, and then let's write out a sentence. pw.println, this is the end of the file. As soon as you're done with the file, you should always close it. pw.close. Now we could run this, and then we could go out and we could look at test.txt, and we would find out that the file has in fact been created. One or more unless there's errors. What have I done now? Oh, it's still complaining I have eat methods all over the place. out there. All right, back to our Printwriter. Okay, compile and run it, and what we're going to see is that it does create our text file. So I could go out in the file system and find that file in my NetBeans projects. Lecture L, test.txt. So we now have a file out there that we could read. So let's open up that file. And we're just going to read these things in as strings and then do our parsing. I could call .nextInt and .nextInt to read those two things and then just use .nextLine. That's probably easier. Let's give that a shot. So now I'm going to do a separate block of stuff. I'm going to recreate my file handle here, even though I could use the same one. Or how about calling it, in file or something like that. File in file equals new file. We're also going to call it text.txt because we're going to read the file that we just wrote. And this is not the only time we're going to be lecturing about files. Now let's create a scanner based on that file. Well, scanner sc except let's not call it sc because that's too ordinary. How about fsc for file scanner equals new scanner parentheses in file. And again, we will get, well, for one thing, it doesn't know what a scanner is, so I'm going to add the import for the scanner. The other is it's going to complain that we don't have a catch that will capture the file not found exception. So exceptions had better be something we lecture about next time. But again, if the code's dangerous, if it throws exceptions, we encapsulate it in a try block. And now I'm going to let it tell me explicitly which kind of exception it throws just by clicking on the error and doing add catch clause. And it also captures a file not found exception. Surprise. So why don't I just copy that statement? I'd paste it there and call it a done deal. Again, it's real lame not to be storing these file names inside of strings so that we could print out which file was not found. All right, assuming we have the file open, the way exception handling works is that if this line generates an error, it jumps to the exception handler and nothing else after this line happens. But if no exception does occur, then it will go ahead and proceed to the next line here. And our data, if I recall, has two ints followed by, so int x is equal to fsc.nextInt, like that. And int y is equal to fsc.nextInt. And let's get our string. We had a line of data. String line equals fsc.nextLine. And we could print those things out if we wanted to. System.out.println x plus a quote comma end quote plus y plus a quote comma end quote plus the line. And maybe we will put some comments here, or not comments here, telling us what we just did. System.out.println read from file. And I should go back up and add another print line that said wrote to file. Now this is the most basic form, right? It's not looping through the file, reading in a whole bunch of stuff until it hits end of file. It's just reading in very specific file format that we were already familiar with because we dictated that it's going to have two ints and followed by a line. So back up here, after we close the file, I'm going to put my print statement that we wrote to the file. System.out.println parentheses file written to. That one was inside the first try block, right? After we wrote that stuff to the file, after we print lined to the file, I had added that file written to. Now I'm going to come back down here. I forgot to close my file. You should always close your file as soon as possible, and there's syntaxes that you can use that guarantee that the file is closed. Supposedly, when the variable falls out of scope, the close method is called on it automatically, but I don't like trusting that, so fsc.close. Now, it's possible that y'all all typed that in as I did. What is this complaining about now? Okay, this is worth showing. Convert to try with resources. I'm going to undo it. Just going to show you an alternate syntax. Okay, it's not going to show us an alternate syntax. Usually the warnings. All right. Here we go. It's showing a syntax where you can enclose as a parameter to the try block a file that you want to create, and then it would automatically close that file at the end of that. But I'm going to undo that. Don't want to see that. Let's run it. We know that file exists. I shouldn't have it open. I'm going to... Oh, that's our notes. And then up here we see that it read from the file 100, 200, and it didn't read the rest of our file. And I'm slightly disappointed in that. I'm not going to take the time to diagnose that. I'm going to turn these into strings and just read them in with next line. So string x is equal to next line, int.nextLine. String y is equal to next line. And it did read it in. I guess it's the old, I've said this before maybe. No, probably not this time. If you start mixing .next with .next lines, you can get into situations where it's behaving in ways that you don't expect. So if you're going to use next line, you may as well use next line for every time you read in. The only thing is that requires you to call parse int or whatever by hand in order to convert the data to an integer. And that's kind of a drag, but our example didn't work. I wasn't expecting it not to work. I thought if next line was called individually as the third thing in it, that it was going to work, but it did not. Let's go take a peek at the NetBeans project for one more time. I want to see the file, see if there's an obvious reason that was not working. No, I don't see an obvious reason it was not working, and it is now. Okay, so as a reminder, if we needed to do something with those values, like add them together, we would need to convert them to ints. We may as well do that. Int a is equal to integer dot parse int parentheses x. Int b is equal to integer dot parse int y. And then we can add them right together. We could do some kind of math. Don't need to actually demonstrate that to, for you to know that we could. Alrighty. So if your project involves reading from a file, at this point, I don't remember any of the projects needing anything more complicated than reading from a text file, which you could do with Scanner. The only thing left to do would be to show you how to write a loop that would scan through the entire file if you needed to read it line by line. So let's give that a shot as our last thing before we close down for the day. Or I should wander around and make sure everybody who's trying to get it to work actually has it working. Typos.
I couldn't find how to tell it to do the catch. So I typed it, and I guess I didn't type it right. Perception.
Delete that
Okay.
and let it add it if we can get it added.
So you just right clicked on it.
No, I'm not seeing the difference.
That's okay, I wanna know how
But
you
yeah,
got it
here's how I did it. I
generated.
clicked on that and did surround, no, add catch clause.
Okay.
Yeah, sure, undo what I just did, control C it. There we go. Let's scroll up to the top for some, scroll back down, it's probably in this mess. Yeah, click on that little arrow, not the big one, not the big
This
one,
one?
yeah, that one.
Right.
I don't know, there, no, click off it and then try it again. The card. Why is it not, there, no? I am left clicking on it, try left
Left
clicking on it, okay.
No, this one.
That one, yep,
Left click.
okay, and add catch clause.
Okay,
And I don't see a difference between what you wrote.
that's all right.
Anybody else? No typos?
You doing okay?
Can I write a loop that will process this text file in 3 minutes? Probably not. I want to give it a shot anyways. File in2 is equal to new file parentheses quote test.txt end quote. We better open it. So scanner sc equals new scanner parentheses in2 in parentheses while parentheses sc dot next or has next line. While it has any data, while sc dot has next line, let's read that line in. String s equals sc dot next line, and then do something with it. Why don't we just print it out? System dot out dot println parentheses quote I just read end quote plus that string that I read. And it's yelling because I haven't put everything in a try catch block, so I need to go insert the word try before scanner here. And it added a closing brace, which I don't want, so I'm going to remove that and come put it after the end of the while loop. And now it's complaining that the creation of a scanner does in fact throw an exception, so I'm going to add a catch clause for it. And print file not found. And let's see if it works. I just read 100, I just read 200, and I just read this is the end of the file. So if you needed to open a file, a text file, and rip through it, that's one way of doing it. That's kind of the most intuitive way to me. Then whatever you need to do with S, you could do, right? If you need to parse it, if you need to split it up into its individual components. We haven't done a lot of string handling that parses data like that. All right, so we know how to create a file, we know how to read from it individually, and we know how to write a loop to read from it. There are other kinds of files. There are binary files. This is all ASCII text. You could open it with Notepad, but if you were writing numbers out and it was a binary file, you wouldn't be able to see them with Notepad. And you can even write out object files, which are the object representation of an object we created. We could write out a triangle or a square or a rat or whatever, and then read it in with a single read call. And now there are some drawbacks to that. So why don't we stop here and make a Dropbox for this. And I know I probably didn't give everybody time. Some of y'all probably had decided not to do the last part, and that's okay. We are in coursework L, which does not have a folder. Alright, then I'll have to create a homework folder for this as well. Alright, the Dropbox is there if you want to put any notes in it.